No, I think maybe 3 minutes ago. So because I checked it maybe 2 minutes ago.
في بالمرة
Sorry?
كلوبس كان speak. شاش
You did not even start it, I think.
No, I didn't start.
Okay. Because this information is very important for you. It will help you in your later on. I will upload this for you. Now, for example, if you want to restrict, you want that your live load should not go beyond this red point. Can you see this red dot? See the mouse here.
Yes.
If you want your live load, the truck wheel should not go beyond this point. You understand or not?
Yes.
How you can do that? Just give this value here. One. If you see now, there's a green line here. So it means now there's a curve there. The wheel cannot go beyond this point. See, the other green line is also moved. This green line.
I keep it the same length for footpath and sorry.
For example, if there is no footpath,
Just sorry.
just barrier. No footpath, just barrier. Keep it 380. See, now these green points have been moved a little bit away. Do you understand? So now, if you see, this is 380 from here to here. Okay? You want this way or
We have foot
1, 3, 4, 1, 3, 4.
if you put it 0, so what does it mean?
That
There's no
Your truck wheel can go on the barrier. Okay. So there are more information, but I think that is about the median. For example, if you want to add a median, you can add median, and you can give the. For example, if you want to add a median, if you want to divide the bridge into 2 parts, one for the left and one for the right. Okay, you have to tell here the distance of median and the width of median.
4,000.
For example, I will keep it 0, and if I put it the width of median, maybe not 4,000, it's too much.
No.
380.
Maybe 380, I think.
Yeah.
No, the distance.
It is from the center line.
It's already considered.
Yeah, it's 0. It is already in the center. But if you want to move away from the center, you can do that. Well, there are many things, and if I go in more detail, we are in short of time. I'm not able to complete what I have to complete today. Okay, so let's move very quickly. You can try this by yourself. I will give you this SAP, but this is the most important information. Okay. Anything else you want to ask? No? Because there are no girders, so there is no need to code the frame sections. It is just what we have now. This is the main part of our bridge slab. The third important step, that is bridge. Till now, what I have explained you. Number 1, what? Define material. Number 2, define general loads, not bridge. Number 3, define layout line. Number 4, define deck section. And now we will move to the bridge object definition. Bridge object. Okay, done. Let me save, otherwise we will lose all this data. What should I, class problem?
Yeah.
Okay, save. Next, bridge. So, now the next option we will study about the bridge objects. Click here. and then go to add new bridge object. Give any name here, my bridge or bridge or class bridge, CL. CLB, class bridge. And please see here the layout line BLL1, bridge layout line, we have already defined will be here. Now, if you see, this is the bridge object. Now it is your bridge object. What is object? Abutment, center line. Okay? You can also add supports here in your bridge object. For example, if your bridge is skew, how you can change it? Do you understand? If your bridge is at an angle, you want me to do that? For example, you want to, we have two abutments, 1 and 2. If you want to do any modification and you are not happy with this, you can go to these options, spans, double click. If you double click on the first option, span, please see on the right here, double click. And if you see section, I already defined slab. Do you remember?
Yeah.
And variation, now you can define variations. Sometimes your bridges are tapered. Slab, for example, above the girder, the thickness become more, and when you pass the girder, the thickness become less. Like I draw one picture here. I don't want to draw it here, and I don't want to waste your time going to the Google.
As a semicircle.
Just like a semicircle or any variation, like parabola, the slab itself. Along the length, slab, if you want to change the slab, you can do the variations. I will do that, but not in this problem, because in the next upcoming girders, I will tell you how you can do the variations. Okay? If you want to do variations, you can just double click, but I just restrict myself, because if I go inside this bridge object needs 30 minutes to explain only. So it means in the spans you can define the variation. I just make it okay, and then abutments. If you double click the abutments, there are two things: start abutment, end abutment. The properties of the start abutment. Now, what is abutment? You know, it is like a retaining wall. It could be a cap beam. It could be a transom. It could be a transom on 3 piers. So, do you want to have a diaphragm beam at the abutment? If you want, you can add it here. Add new diaphragm. Okay? Like the thickness of diaphragm. If you want to add, but if you don't want, no need. Okay. Now, here there are at the abutment. If you see abutment property, I click it here. BAT V1 modify show bridge abutment. Click here. Now please see these two things. Number one, girder support. If your slab is on a bridge girder, so, or if it is a girder bridge, which option you will take? Integral or connect with the bridge girder bottom only? If it is a slab bridge, okay? So in case of slab, you want to connect the slab as a part of abutment, or just you want to connect the bottom of slab to the abutment.
The path.
Do you understand what I'm saying?
Yeah.
Like on a column, when we have a monolithic joint, the slab and column, the beam and column, they are just like one part. You want to join the slab with the abutment, or you just want to seat the slab on the abutment.
You just see.
in our problem, it was simply spotted. It means the slab is simply resting on the abutment. Do you understand?
Yes,
Yeah.
no.
So it means just connect the bottom part. Don't integral. Integral means now it is the part of abutment. So this one, foundation spring. Now again I make it this. What type of, for example, what type of foundation is for the abutment? Is it fixed or abutment can move?
I think. Move.
If it is a steel column, abutment which is made up of steel, or it has steel supports, then it can be pin connection or hinge connection. But if it is a concrete, most of the time we take it fixed. Or there is one thing which is in between fixed and hinge, that is partial fix. You can do that. But for this case, let's take it fixed. I don't go to define this property, foundation spring, and here I will define the spring. See, U1, U2, U3, three movements. The slab, this is U1. You want the slab to move in this way? You want or not? You want to allow your slab to move in this direction? You want to allow your slab to move in this direction? You want to allow? What is roller support? In roller support, I explained you can allow U1.
Yeah.
But U2, U3 you should not allow.
Yeah.
And for a hinge support, all U1, U2, U3 it should be not allowed. So it is fixed. It is like a fixed support. But you know, if I am the design engineer for a simply supported, please see here, it will be free. These three will be free. For a simply supported, you want to allow movement. Movement will be zero. If you make it free, the movement will be zero. But if you make it fixed, it will be like a fixed support. So
You want.
what I am doing, I am not allowing any movement vertically and horizontally, but I allow the movement. Movement means the slab can rotate. When it will bend, it can rotate. Okay? Or if you want to allow U1, sometimes we allow U1. We want, due to expansion, we want that, okay, slab can move in this direction. So you can also free, these are the foundation springs. I'm sorry, these are the foundation springs. So it means now your support is like a hinge support. But if you want to make partial fix, you can also do that. Partial fixity mean if you say 50% fix. But if you want a fully fixed, make it fixed. This is the foundation of the abutment. Fixed. Now it is fully fixed. Okay, okay, and here it is fixed. Okay. Abutment. This is the start abutment. Here, now here you have the control of the bearing. If you see, the slab will rest on the bearing first. You know bridge bearing?
Yeah.
Yes.
Anyone of you who do not know the bridge bearing? Okay, bridge bearing. I click it here. Now, again, add new bridge bearing, or you can use this one, modify and show. The same thing which I told you we can allow. For example, in the bridge bearing, we allow the moments, but we don't allow we want that the slab can deflect and do not give movements. So for the zero moment it should be free. But if you want that, if you make it free here, it means now your slab can also move in the one direction. But slab cannot move in this way or in this way. But it can move the slab itself. For example, if the wheel comes, the slab can move this way. We allow this movement for expansion. we have expansion joints. Okay, and also the abutment is like this. The slab is resting here, so abutment will not allow the slab to fall on the either side, but it will allow the slab, the bearing will allow the slab to move this way. So the little bit, if it moves, what will happen? Why will allow this movement?
Certain loads might happen.
Because if we don't allow, it will become more, we need more strong slab. There will be more stresses, there will be more forces. Do you understand? Okay, so this is a bridge bearing. Here we can define what type of bridge bearing we have. So it means I want my slab to move in one direction. Not like 1 meter, maybe like few hundred millimeters. We will see this. This is the which abutment? Start abutment. Okay, now let's click it here, end abutment. Don't allow the movement of slab on both abutments. Just on one abutment. It is just like one hinge and one roller. Do you understand?
Yes.
If you say here U1 free, it means 2 rollers. Let me show you. If I click it here and I again, now here I should add new bearing B2 and here it should be fixed. Okay. Okay. And I should make bearing 2. This bearing 2, what is this bearing 2? This bearing 2 do not allow the movement in the one direction. It is fixed. It is like a hinge. I'm telling you, I know these things are a little bit complicated for you. But if I just go and tell you how to model, maybe I can model this bridge in 5 minutes, to be very honest with you. 5 to 10 minutes I can model your bridge. Or maximum 15 minutes. But the purpose is to educate. In an online video, I'm sure you cannot find these things in such a detail. Even you will be always confused. What is this U1, U2, U3, R1, R2? So that is why I'm moving very slowly. So it is the bridge abutment 2. This is 1. In 1 we have this 3. So now please see here. Now the start abutment, this is the bridge bearing. End abutment, the bridge bearing is 2. You can define as many bridge bearing as you want. But we need 2. Yeah.
For the hinge and roller, for both, I mean for the apartment and for the
Foundations.
For the bearing and for the apartment foundation.
You can do that. It depends upon your design. What is the type of your apartment? Okay. Yeah. Start and end both. You should do that. For example, for the apartment, at the end abutment.
Has to be fixed.
Yeah. Modify and show bridge abutment. It is fixed. If you want to free pin or anything else, you can do it here. Okay. Same thing. Okay. Now, please see here, the elevation. In the left line, what is the elevation of your bridge bearing? 1.8 meter from 0 to down. This is your layout line, 0, 0, 0. You put layout line 0, 0, 0. So this minus 1.828 means the bridge bearing is somewhere here. You understand or not?
The distance from the tip.
Yes, minus 1.8. And abutment elevation, substructure location elevation or abutment. Do you understand? Abutment is below. You can adjust, for example, if you want to move your abutment, you can do that. For example, you can put the bearing and abutment substructure location at the same level, like let's say 2000, very close. Maybe the bearing height is 200 mm. Okay. This is the abutment. Now bends. You want me to continue? Okay. Now it is saying there are no bends. If you click on this, it means there are no bends. There are no bends. So how you can add a bend?
You have to notify the station first.
Yes. Just add here 4000. Add it. Please see this blue line. This blue line is a bend. Bend means one column here, and a trousers. Cap beam and two columns. Cap beam and two columns under the slab. Where? At 4 meter.
So it doesn't have to be like this.
It is in the plan view. This shape is the plan view. Do you understand? This is not the elevation. You want to add abutment? For our bridge we don't have. But if you want to add, this is what I told you. You should add stations first. 24 meter total, and then add here, and after every 8 meter abutment. If you want to do that, I'll do one problem for that. But now if you have abutment, now let's see. This is the span one, and the bend is at 4000. And now at the abutment type of bearing, of course you need support under the abutment. The slab and abutment should be connected with the bearing. The same thing for the bearing. Now you want this continuous? Yes, it is continuous. The slab will be continuous. Diaphragm. Now the bend property. This is the most important thing. If you click it here, you have to add or modify a new bend. Cap beam length. This is the length of cap beam. I'll stop my class here, and from here I will continue from the next time, because I have to explain you many things in the apartment. But still we have not started the. You did not see the physical bridge. Okay? But if you give me like 5 minutes, I can model your bridge from now onward if you want. For the upcoming lecture, I will explain you from here, from the bend. But if you want to see your full bridge, I can do it right now. You want to see? You want to see?
Yeah.
Okay. Now please see. I will not explain. I will explain you in the next week. But just if you want to see the physical model, you can see that. Okay. Because for your bridge there is no bend and no super elevation. I will give. There are no tendons, no stage construction. Okay. So I don't have. And if there are skews. For example, if you want to skew the bend, like if you want to move, okay, no, okay, done. This is the CLB, and now I will go to bridge. Now please see what I am doing. I will not speak anymore, but I will complete your model. What I'm doing, don't ask me, okay? This is the first deck section. If you want to see how is your deck, I can show you. Okay, but no lanes still now. Okay, now let's go to the bridge. The lane width we should have 3600. 0 center line offset I want from the center line it should be 1800 or let's suppose 2000. You want this color? Okay, fine. This is your lane 1. Add new lane. This is the lane 2. Zero. This is minus 2000. Color, I would like to see green. Okay. So display. So these are now your lanes. Now we will move to the vehicles. There are so many types of vehicles. We have HL93 as well. These are some old trucks. If you want to use any old truck, you can use that one. If you want to see this one, this is the truck itself. The first is 35,000 kilonewton. If you want to see in kilonewton meter, well, I'm just showing you this. 35, 142, 142. This is the same close to HL93 truck. Okay. If you want to add tandem, you can add tandem here. For example, if you want to add any other vehicle, this is tandem, as truck and tandem. Okay. So I add these two. Okay, now I will add the class bridge. This will be the HL. I call this class. It has truck and tandem. I will call this class HL93. Add scale factor. Or maybe the dynamic alarms here I should give 1.33. Okay. Now we have vehicle class, and now we can go and define. For example, bridge loads, define